Let's get into it. So, I am really excited about tonight's talk. I've been thinking about this topic for months. I think it must have been back in like March or April that I actually reached out to Sharky and said, hey, I want to speak on this topic that I've been really kind of interested in, and here we are finally, which is great. There's something in this talk for everyone. I think even if you are brand new to JavaScript, you've only been doing it maybe for a few weeks, you will come away with some really powerful techniques that you can use to apply in lots of different contexts. For those of you who have maybe used functions like, I'm just going to turn this maybe down a little bit. All right. For those of you who have probably used Throttle or debounce before from Lodash, hopefully tonight I will demystify what's going on. Even if you just know which one to choose going forward, that would be a big step up. But I'm going to be live coding both of those from scratch, with the idea being that you will learn how they work and be empowered to hopefully make your own. You'll see that there's actually not that much code to write them, and they're pretty opinionated, and you can have your own opinions about how they work, and you may want to make your own ones for your own use cases as well. Cool. So with that intro out of the way, here's some tweets that I put out, and I just sort of hold this sentiment that I've been thinking about for a while, which is that if you want to have performant applications, you just want to ask the computer to do less work, right? Computers are really good at doing nothing. The less you ask them to do, the faster they're going to be. And a lot of performance engineering is just simply asking the computer to do less. Yeah, and that has held true for me in lots of different contexts. There's probably a layer beyond that, which is whatever you do, try and make it fast. But for the most part, it's just avoiding work. So, rate limiting functions. You probably can't read out back, actually. Rate limiting functions. What problem do they solve? So, this is a pretty typical use case. You might have a function here. I've called it expensive. It's an expensive function to run. And it might get called every so often, and then you get results coming out of it every so often as well. And this is fine. You know, your application continues on without any performance issues. And then you get a situation like this, where your expensive function gets flooded with calls, whether that be events or other things, and you get jank. Your performance in your application goes down quite a lot because you're trying to do too much work. You're asking the computer to do too much work. So rate limiting functions are simply putting a wall before your function. You can think of it as like a filter or a limit. And the kind of idea is that this thing kind of takes the barrage of function calls and calls your more expensive function only every so often. Okay? This is the big idea. This is what they're trying to do. So you have all these things coming in, but you only take a few of them. And by doing this, you can drastically improve the performance in your systems. This is like across lots of different systems, this is such an important performance tool to have at your disposal. So in the wild, throttle and debounce. These are the two most common forms of rate limiting functions. I'm quickly going to go over how they work using diagrams. So this is here. This is an example of a debounce function. Oh, check that. All right. So over here, we have lots of different calls, okay? And you'll see that there's to this debounce function. And the last one starts a timer. Once that timer expires, your expensive function will get called, okay? Every new call resets this timer. So you can keep calling it. It's only from the last, like every time you call it, the timer keeps getting reset. And it's only after a period of inactivity that this function here gets called. All good? So debounce, you need to know the latest value after a period of inactivity. So a really kind of common use case for this is a user picker. So if you're, say, listening to key down events, and in response to those, you want to fetch some data from the server and bring back the most relevant users according to that text, it might not make sense to call after every single key down. I'll put it back on the diagram so you can kind of see what I'm talking about. On every single key down, because before you've even called the server and it's come back, they've already typed another character which has invalidated that last query. So it might make sense to wait 20 milliseconds, 50 milliseconds, 100 milliseconds, I don't know, before you actually make that call. It saves you a ton of work on the client in making all these requests that end up getting aborted anyway, and it also saves your server a lot of work as well. So yes, you need to know the latest value after a period of inactivity. Worth pointing out before I move on is that these functions, these rate limiting functions, lose data. So what I mean by that is, a debounce function will only get called with the latest arguments or the latest value to that function. Okay? So say it got called with 1, 2, 3. The last call was 3. That's what would be actually called to this one. So you've lost those 2 other ones. Okay? So if you have a use case where you actually have to know every single value, then you can't use this technique because you drop calls. Okay? But in the context of, say, a user picker, it's okay to drop those calls because you don't care about them anyway. You only care about the last one. Okay. Now let's take a look at Throttle. It's similar, but different. The idea being that the timer starts when the first call happens, and it will be executed with the last one. So unlike the debounce, where the timer is reset, for Throttle, the timer will not get reset on subsequent calls. Okay? So if you look at this one, this is where the timer starts. We get 2 more events, and we kind of wait a little bit, and then this one gets called, this one here. So that timer did not get reset. You can see the purple bar. The timer started when that call was made. Okay? And same again here. We have 3 calls. The first one starts the timer. The third one's the actual one that gets called with the value. So when would you use a throttle? This is when you need to regularly know the latest value. So say you had something that wanted to listen to scroll positions, say you were having to move something in response to scroll, and you needed to know the latest scroll, but you don't necessarily want to be flooded with every single scroll event, because browsers can actually fire like 100 scroll events a second. And if a user can only see 60, that's automatically 4 that you don't need. But maybe you could have dropped a number of those, depending on what you're doing with that value. So this is the scenario where, say you're listening to scroll or mouse move, and you want to know the latest value, but you're okay to drop a few, right, for the sake of performance. That's it again. So, as with debounce, these 3 first calls actually get dropped, so their value is gone. You can't get it anymore. You only get the last one. All good? All right, so that's Throttle and debounce. Hopefully that helps you to choose the right one when you are picking these sort of rate limiting functions going forward. There is a variant of Throttle called with leading. This is actually the default in Lodash, I think. And that's so it's a variant on that one I saw before. And the idea being that the first time the function is called, if there's no existing timer, it will execute immediately. So you can see in this case, it's executing that function immediately, and then these 2 red, that starts a timer, these 2 red ones get dropped, this third one comes in, there's nothing, and then that one happens. So it's very similar to that last one, except we have these green events now. Where if there's no timer running, so in this case there was no timer running, that call happens straight away. Okay. That's the default in Lodash. You can turn it off, I think, with an option and say leading false. But yeah, that's sort of a variant on that as well. All right, let's get into it. We're going to code these up, see how they work. Yep.
Dim the lights.
Okay. Is that font size okay for people at the back? Her TV's close there. I don't want to go too much bigger because I want to be able to fit the code on the screen, but this is a little thing I coded up. It's like a little REPL just for fun. right? It will hopefully just re-execute when I save and give me the output of that file. Saves me just having to type node, whatever. And also I'm using flow, so I can run it through Babel and have nice flow types, but doesn't matter about that. Anyway, so I have notes because I can't put them on the same screen. Now, this is cool. All right. All right, so what I've done here is I've created a function on the outside called outer, which returns a new function called inner when this is called. So I'm creating this new function here. This will be an inner function, and then I'm calling that function. Ugh, that's a lot of words. I probably should choose something other than hi. And this may be new to you. You may not have seen this before. The idea that a function can return another function. And this is what's known as a higher order function. Like, congratulations, you're now like, you know, your functional programming skills have now leveled up. Like, this is kind of as simple as it gets, right? I haven't used arrow functions here just to make it really clear, but I also could have done like const outer equals blah. That's the same thing. And I will comment that. Cool. So same idea, but maybe it's a bit clearer with the function keyword. So that's a higher order function. Cool. Functional programmers. Now, that is the first part. The second part. Functions can return functions. If you haven't known that, just get on that. That's awesome. Cool. Hello, Alex. That's my name. This is two really exciting ideas in one very short example. This is the idea of function scope in JavaScript. So the idea that inner functions have access to the variables that are declared inside of the outer functions. This is awesome. This is how JavaScript scopes things. And we've also created a closure. So if you've never known what a closure is before, this is it. So this name variable here, when we create this, when we execute this outer function, it's technically gone. Like, you can't get to it anymore, but still the inner function has access to that variable. So that other variable, they kind of say it as it's being closed over. You can't get to it anymore, but it's still accessible in the inner function. As a closure, so you've learned about higher order functions, function scope, and closures. Awesome. All right. Now, all right. Right. All right. Hopefully it's just I don't normally use function declarations, but it's just hopefully a bit clearer to see what's going on. So what I've done now is I've created a function called add, which takes an argument and returns a new function, which also takes an argument and then returns this one here. What the important thing to note is that this wrapping function is exactly the same as that last example we saw. This counts as a declaration. It's still accessible inside of this inner function. Okay, even though it's an argument, counts as a declaration. Cool. And that's it. That's enough sort of background knowledge for us. Oh, what was I going? That's not enough background knowledge. All right, here we go. Const debug. I'll explain what I'm doing after I type it. Okay. Thanks. Thankfully I got flow and prettier, so hopefully it won't be too bad. Okay. Now, this isn't very exciting right now. What I'm doing is, if you didn't know this, you can pass functions as arguments to other functions. I know. So in this case here, we have a function called debug, which takes a function, returns a new function, and then calls that other one when it gets called. There's a lot of functions, might be a bit bendy. This is the thing that we pass in. You can see here, I've used the arrow syntax here, but I'm using what's known as the rest operator here. And it's just grabbing all the arguments, putting in an array, and then this is using, I think it's the spread, same idea, but you're applying these arguments to this function. Pretty straightforward. So in this case, we call wrapped hi there, and it's just passing these things straight on to console log. Now we could enhance this function to do some other stuff. So we could go, hey, console log, like, you're about to call this with args. And then we could even go like const result equals that. And then here was your result. And then we can return it. And we'll do something a bit more interesting here. And then we'll pass in just 1. I'll just do 1. Okay, so that works the first time. Yep. So really interesting, like we were able to wrap that function in some debug information, right? So we return a new function. So according to consumers, like they're just calling, so this is our actual function, value, and we return value plus 2. And we've wrapped that inside of another function that we return here, that's this one here. And we've been able to log out some information about its argument and its result. Like pretty cool, pretty cool. So we've enhanced that original function. And this again is another higher order function. And now we have the tools that we need to actually get started. All right, so explain why I'm not using arrow functions in a sec. Okay, so this is our debounce function. Doesn't do anything right now. It just takes a function and wait for us. This is the period of time we want this debounce to wait. So in terms of its inactivity before we call the underlying function, which is this one here. So what we're going to do is return a new function, which is just going to spread the args again. And call set timeout, if I can type. Okay. Now, this is what we are starting from. So now we're delaying the calls to these functions. So now we're going to have our debounced function. Don't know what's going on there, that's kind of worrying. Equals debounce, and we'll just do straight up console log. Right, I'm going to debounce 1, 2, 3. What's going on here? Thanks. Yep. All right, cool. So it might not be super clear, but we're just waiting 100 milliseconds. So we call these, and every single one is going through. We're not doing any filtering yet. We're just delaying the function by 100 milliseconds. So we've actually just created a delay function, if you wanted to use that. Okay, so how about we actually try and do that thing we wanted to before. So to do that, we're going to do let timer ID equals null. So we're going to grab a reference to that ID so we know what it is. We're going to say, hey, if there's a timer ID already running, like we need to clear timeout timer ID. So we're going to abort any existing calls that are happening. We're also going to create something else in the upper scope called last arg. So this is a reference. So whenever this, I'll show you what this does. Hold up. Oh, my bad. Live coding, awesome. Awesome. So we have a fairly, we'll probably want to set this so we can do it again. So what have we done? What's going to happen is we have these arguments coming in. These are the new arguments. We're going to set the last one. So these are the ones that, you know, we're losing a reference to whatever the previous one was all the time. We're just constantly losing whatever the last one was. So we keep a reference to it. If a timer has already started, then we want to clear that timer. We don't care about it. And if we haven't, then we're going to create a set timeout and wait for it. And you just created like a really kind of basic debounce function in not that much line of code. So let's make this a little bit better. We're going to now assign that to a result variable. Another thing you may not have known is that functions are objects and you can add properties to objects, you can add properties to functions. So we're going to have a cancel function. I'm going to define this up here. So this is the thing that we're going to use to like abort our existing call. So if there's no timer ID, we can just do nothing. If there was a timer ID, we clear it, set it to null. We can also do this in here so we don't repeat ourselves. Great, and we just need to return result, sorry. All right, so I forgot to show you the fun part. So now when we go here and we go debounced, we have a set timeout. Debounced for, right? In this case, we expect to see the number 4, okay? So even though it happened 50 milliseconds later, it did not exceed this wait for time. So it's going to thrash, it's going to override that existing 4. Now, if I made that 150, we should get 3-4 because the first one happens in the first 100 milliseconds and then this next one will start the timer again and then the next one will call when that's done. Okay? We could also do a debounced.cancel if we wanted to, and this will abort that first call that is mid-flight, hopefully. Oh, 150. Ugh. Yeah, if I do that, well now I should just see the number 4. Awesome. All right, so that's like a debounce function, right? And this is probably like as complicated as it needs to be. I've even sort of accounted for, without being explicit about it, that this will lock the this keyword context to whatever it was when this function was created using this arrow function here. I was careful not to use an arrow function on the outer one because that would have locked the this context to undefined. So by simply using it here, I have now made it kind of work pretty well with how you probably expect it to with running in different contexts. It will now respect the context in which it was created. Awesome. You don't need to use like .bind or anything. We could do something a bit more complicated, but this is actually like pretty robust, just doing like this. So there you go. That's debounce. All right, now throttle. We will begin again. Actually, I'm going to keep that just over here for now. So I'm going to come back to it. Start from, I'll just keep those for a sec. Okay, so now we're creating throttle. So we've created debounce, which is wait for a period of inactivity before calling the function. Now we're using throttle, which will call regardless of the timer won't get reset when new calls come in. So we're going to return a new function, which is going to call this function with the args, wrap it in a set timeout again. Okay, so we've now recreated that that delay function again. So we're just delaying them by 100 milliseconds, but we want to introduce this idea of throttling. So again, we're going to create a reference to timer ID. I'm going to create a timer ID, sorry. Let the last arguments do an array. Last args equals this args. Now, if there's a timer ID, we don't need to do anything. Okay. Before we were canceling the old one. Now we're just saying, hey, like that can run. That's fine. I don't need to do anything. Timer ID equals that. Instead of args, we're going to use last args. This is a reference that exists outside of that function, so it's going to keep being updated. I think that's it. We'll see. Cool. So now only the last one's being called, which is what we expected. But now we've got to get into this fun stuff here. So, oh man, my pen's not working. I'll do the cancel in a sec. All right, what do we expect to see here? This is still in the same time period. All right, so it'll smash that. Crap, man's not working. Yeah. I had an example. Let me just pull it up. Oh yeah. You're right. What's an example that's going to execute a throttled? We can show that it's not resetting this timer. Oh yeah. If I do like 90. So this is 100 minus 10. Yeah, that's fine. Okay. So 4 happened in that first 100 milliseconds. So we see it, and then we also see the 5. So we can see that there's only a millisecond difference between them, but that timer didn't reset. It's being sucked into that next time period, which is pretty cool. And again, we can create, instead of returning this, we can assign it to a variable, result equals that, return result. And again, we're going to add a property to the result function. Boom. Now we go cancel function too. Not that it would make much sense, but you could do throttled.cancel. So say you're a component and you're being unmounted, like it might make sense for you to get rid of this call, like you don't want it anymore, you don't care about its values anymore. Maybe the user has done something else, which means you don't want to be getting updated anymore. You can use that cancel function to do that. And again, this will work correctly with like this context because this one's not binding it, this one is. So whatever this context was, when you create this function, that'll be maintained, which is pretty awesome. And that's it. That's pretty awesome. Like we just created throttle and debounce in like a few lines of code. And I'm going to show you something really interesting as well. Well, firstly, I'll grab that just in case I lose it. That'd be bad. All right, so we're going to go back to our debounce function. And this is, oh, actually no. Let me keep this throttled. Okay. So what if instead of using set timeout, we use some other like thing, right? Jared's smiling at me because he knows where I'm going. Like, we don't have to use set timeout for these sort of things. Like, you could use, I shouldn't have pressed save because now it's going to go crazy. Cancel animation frame, sorry. I don't think request animation frame works on Node, which is fine. But the idea is here, like, we've now created a throttler which has nothing to do with milliseconds and is based on request animation frame. And this is almost character for character, a library that I've made called RAF Shed or RAF Scheduler. This is a throttle function that uses request animation frame, which is pretty like crazy. It's going to throttle your function down dynamically based on how fast the browser is that you're using. So if they can only handle 30 frames per second, like your function's only going to get called 30 frames per second. And you didn't need to do any crazy math or anything. Like this is a library that I wrote. Like it's pretty embarrassing that this is big, but like this is legitimately a library on NPM that you can just pull down and use. But it's like, this is the code that drives it. Like there's nothing else really going on. The library I wrote uses flow types, so it kind of gives you a bit more of that, but really you could just write yourself. You could use like request idle callback, potentially as well. You can kind of go to town on these. And I didn't mention as well, like in the example I gave at the beginning, we had this idea of leading. Like I haven't done that in these throttle functions. So you could add that. So like if there's like no timer, you might say, hey, like, let me go back to this. If you wanted to introduce your own like leading, so the idea of like when there's no timer, it, oh, I went too far back. Ugh. Jumping between throttle and debounce. Here we go. Okay. So if there's no timer ID, like call the function straight away. Awesome. Like now you have leading. And we're just going to just do a little check in here that like if args equals last args return. Like boom, now you have leading. Like that is now a throttle function which will call itself if there's nothing pending and will not call itself if there is stuff pending. Right, so all this is doing is I've now said, okay, if there was nothing pending, I call it straight away. And if this set timeout finishes and the args were the same as the last args, which means that it's still the same like execution, we've already called that function, so we don't need to call it. And we can just abort. There. Boom, done. Like that's leading. Like you can kind of see how you can add these things, like, and we could have done that with maybe an options object or something, but just want to kind of, I'll get back to this now, because it will be helpful to have. Like hopefully you've seen tonight that like these things aren't that magic and you could actually build your own depending on your own use case. Like if you have something where you really need to have very specific throttling logic, like it's not that complicated, it's just JavaScript, it's just a few lines of code like this. It's just exercising some language stuff that maybe you're not super familiar with, but actually isn't that complicated. So tonight we looked at like, you know how to create higher order functions. Like this is just a big scary word for a function that returns a function. Like it's not that scary. You can pass functions into functions, and that is awesome. And you also know how to create rate limiting functions. Like you could go off and create your own debounce and throttle and whatever else, or any other rate limiting function based on any other thing you want to base it on. And that's completely fine. So I hope you feel like empowered, not only to go off and create your own like throttle and debounce, because you probably won't, but like to use these techniques to like make your applications like more powerful. We saw like these really interesting language techniques to achieve some pretty wild ideas, and hopefully you can take that away and apply it in different contexts as well. I really like this book series. It's probably my favorite book series on JavaScript. Definitely recommend this one here. I think this is number 3. It's only a really short one, and it kind of goes into functions, how to use them, function scoping, all this kind of stuff. Very compact, but really, really good detail in that one. So if you're looking on like further reading on dealing with functions and doing creative things with functions, definitely check that out. Cool. Thanks everyone.